So scrolling down, I see another to-do down here. This one looks pretty good. I'm actually creating a task called a minimum refresh time task. And if I show you here in the sample app, when I do a pull refresh, you'll see it spins for a minimum number of seconds. And this is a little trick we use as mobile developers because, again, sometimes those values get cached and sometimes that API call can return in just a couple hundred milliseconds. And since, blinking your eyes takes 300 milliseconds, if these results come back in 200, 300 milliseconds, that's not enough time for the user to even see that this pull refresh indicator has shown up. So what happens is sometimes people will just keep refreshing, thinking that nothing's happened, thinking that the pull refresh indicator didn't show up. So something's broken, they force quit the app, gives us 1 star. So what we do, the little trick we do, is to have a minimum refresh time where I say, I want that activity indicator to appear for at least 2 seconds. And then down here in the finally block is where I'll wait for that refresh time task to finish. So a couple fun facts here is that you can start a task. So task.delay is actually starting the task. So this timer, this 2-second timer is counting right now, even though I'm not awaiting it. We can store that task as a variable that we action upon later. Now, that's not actually what we're going to refactor here. What we're going to refactor here is the fact that we're not passing in our cancellation token. And one thing we always need to do as good C# developers is anytime we create an async task method, we always want to allow the developer calling this method to pass in a cancellation token because this task could run forever. I have no idea as a developer consuming this library how long this refresh task is going to last. And, it's a really bad user experience for my user to sit here watching this activity indicator spinning around for 10, 15, 20 seconds. They're not going to enjoy that. Again, that's a great way to get another 1-star review in the App Store. So when I call this method, what I'm going to do in my code is to cancel the token after about 15 seconds because I don't want my users thinking that the app is broken. Rather, I want to cancel the token and then I can display a notification to them, letting them know that there's a poor internet connection detected and recommend that they change their Wi-Fi network or, if they're on 3G and train running through a tunnel, then they know there's nothing they can do about it until they get out. But the problem here, and what we need to refactor, is we're not passing in this cancellation token to task.delay. Now, the good news with task.delay is we can just pass it right in. And that, in fact, that's actually what I'm being yelled at about. JetBrains is letting me know that this method has an overload with cancellation support. What we're going to do is just pass in the token. So now this task will cancel when I manually cancel my token that I passed in after about 10, 15 seconds to let the user know that we've detected a poor internet connection. Thankfully, the .NET engineers are good C# developers and they allow me to pass in a cancellation token. But if you've done C# for a while and you've done async await long enough, you've absolutely come across an async task method that does not allow you to pass in a cancellation token. So what do you do there? Well, the good news is there's an extension method called waitAsync where we can pass in a cancellation token. And essentially what's happening here is waitAsync is bolting this cancellation token onto the original task. So if you ever find yourself in a place where you're unable to pass in a cancellation token as a parameter because somebody who's not us, who's not great C# async await developers don't allow us to pass in a cancellation token, well, that's okay because we can always bolt on a cancellation token using .waitAsync. But for now, in this specific example, since task.delay allows us to pass one in, we'll pass it in the right way. And we're done with that refactor. So the next refactor, right here, I see we create a variable called top stories list that awaits get top stories. And just to show you the way the Hacker News API works is we first have to get the top story IDs, and then we use each ID for each story, and we iterate over those to actually get the title, the author, the number of points or upvotes that it's received on Hacker News, which is how it gets to the top story page here. Get top stories is making multiple API calls and then returning all of that data here to us as a top stories list. Now, this code looks pretty good because we're using async await. We're passing in our cancellation token, but there's actually a performance improvement we can make here. And to really understand how this performance improvement works, let's walk through this task one more time. So let's pretend that thread 1 initializes this refresh method, which is likely the case given that this refresh method is triggered by a user event, by a pull to refresh here. So because user events are triggered on the main thread, it's very likely that thread 1 is calling refresh. So let's say thread 1 calls refresh. It enters into here, initializes our minimum refresh time task, enters our try catch block, initializes this variable top stories list, and then it hits this await keyword and it returns. So great. Thread 1's back interacting with the user. So as I scroll the app, it doesn't matter that activity indicator is still spinning because I can still interact with the app. It is not frozen, all because thread 1 is free. It's available to interact with the user thanks to this await keyword. But when get top stories finishes, it actually shouts back to thread 1 and goes, hey, I'm all done. Get back in here. And that's when thread 1 jumps back in and continues on running this code. So thread 1 clears our top story collection. And then thread 1 iterates over all the top stories in our list, adding them into a sorted collection. Is that really what we want? Because how many stories are on the list? What if there's 5 million stories that came back? Well, that means thread 1 is going to have to insert those into a sorted collection one by one. And that O of n is very, very complicated. I think it's O(n) squared because it has to first go through to see if there's already an existing title, so it doesn't add any duplicates. And then it has to add it into its specific slot in the sorted collection. So this is a very computational task. And if thread 1's doing this for 5 million top stories, well, even if each of these only takes a millisecond, 5 million times 1 millisecond, well, that's 5,000 seconds? Assuming I've done that math right. And that means thread 1's going to be locked up for a long time. So do we really want thread 1 running this code? No. So what we can do is on our task, on our get top stories task, we can say configure await false. And what configure await false does is it allows the code here to continue running on a background thread. So if we walk through this code again, let's say thread 1 calls refresh, initializes minimum refresh time task, initializes top story list, it hits this await keyword, and it returns. Meanwhile, get top stories is running in the background. Let's say get top stories is running on thread 5. So when get top stories finishes now, because we've added configure await false to our task, when thread 5 finishes, instead of returning to thread 1, it goes back to the thread pool and says, hey, are any of you available? And whatever thread is available from the thread pool will jump back and continue on. And so this is great because now we know that thread 1 isn't being bogged down with this complex for each loop that's going to take a lot of time. We know that thread 1's free to interact with the user. And we also get a slight performance bump here because we just grabbed whatever thread's available, meaning we weren't waiting for the calling thread to complete. Before configure await false, before we added this on, we would have to wait for thread 1 to become available to finish writing this code. So that means if the user was constantly scrolling our list, or maybe they're already clicking through and reading stories as the results slowly rolled in, well, thread 1's going to be busy. What's our code doing in the meantime? Nothing. It's just sitting here waiting for thread 1 to free up before it can jump back in and finish running this method. So by adding configure await false, we ensure that we don't accidentally lock up thread 1, our calling thread, our UI thread, and we get a small performance bump because as long as there's a thread available in the thread pool, which there likely is, this code will continue running almost immediately. Okay, let's scroll down to our next refactor. Yes. So you were probably already looking at this earlier when I was explaining our minimum refresh time task. So remember, this is a task that I kicked off. It's running already. It has been running the whole time this code has been running. But then when we enter into our finally block, this is where I want to ensure that this task is completed, that it's finished essentially running for 2 seconds before we say, is list refreshing false, which is the cue in my .NET MAUI app to make that activity indicator disappear. So when is list refreshing equals false is set, that spinning indicator will go away. So here, I just want to wait until we're done. And here, I'm using the .wait keyword. Now, I have a rule of thumb around .wait and .result, and that is never, 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 never use .wait and never use .result. These are really dangerous as well because .wait is actually a blocking call. What we should be doing is just using the await keyword because yes, fun fact, you can use async await in a try finally block. And this will ensure that we don't block the calling thread because remember, when the calling thread hits the await keyword, it returns until this task is done. And if that task is already completed, then the calling thread doesn't return. It just continues on to the next line of code. But in our first example, we were using .wait. So .wait in this case, this is telling the calling thread, you cannot return. You have to stay right here. Meanwhile, I'm going to finish running this task, this minimum refresh time task on a background thread. Let's say, hypothetically, that thread 1 gets down to here and calls .wait, and the minimum refresh time task still has 1.5 seconds to complete. Well, .wait tells thread 1, okay, you stay right here. You are not allowed to go anywhere until this background task is finished running. And that means, because it's thread 1, our UI thread, that now our app is frozen for that remaining 1.5 seconds. And this is never good. We never want to use .wait because